Hello everyone, welcome to Ajiro Tech. Ajiro Tech. In this video, we're going to be looking at monitoring and control, and it's right from the Cambridge AS/A levels. Okay. Now, I'm doing this video because it's coming at a time where some students are preparing for their exam, and they reached out to me and they were like, Agile, please, I need you to teach us this aspect. And that is what I'm doing. Okay. And so please do well to subscribe if you've not done that. Okay. And now we can begin. Now, in this lesson, you will be learning the following. The first one, right there on your screen, is about the sensor and calibrations used in monitoring technologies. The second one is about the uses of monitoring technologies. The third one here is about the sensor and actuators used in control technologies. And finally, how to write an algorithm and draw a flowchart. I've done a video about algorithms and flowchart. It's right there on my YouTube channel. And also, please, in my YouTube channel, there's what we call a playlist. So the whole essence of the playlist is to make it easy for you to just navigate through my channel to know what you're looking for. Trust me, Agile Tech is loaded with a lot of resources for your personal studies and your group studies. Okay, so for the Cambridge AS/A level, there's a playlist for it, so you can go through it and then you could actually see the video, or you could just go to my YouTube channel and search. Okay, and then you will find what you're looking for there. Okay, monitoring technologies. Now, monitoring technologies or monitoring or measurement involves the use of a computer or microprocessor based device, okay, or microprocessor based rather device to monitor or measure physical variables over a period of time. It's right there on the screen. Now, when we talk about monitoring technologies, we are using a computer or a microprocessor based device to monitor physical variables over a period of time. It is important to know which sensor would be appropriate in each situation to measure physical variables. Now, on your screen right there, I put down some of those physical variables that the microprocessor measures. We have light, temperature, atmospheric pressure, humidity, moisture, sound, blood pressure, pH, carbon dioxide, and among others. Now, in chapter 1 of the Cambridge AS/A levels, there's a section we talked about data logging, and I've done a video about this. It's right there on my YouTube channel. So if you've not watched it, please, you have to, because that will make a whole lot of sense what I'm saying right now. So in chapter 1, we talked about data logging, okay? And we saw that we've learned that a device or a sensor is a device that is used to collect data. That is what a sensor is. So a sensor is a device that is used to collect data. The collection could be the collection, or if you want to rephrase, is an input. Okay, so the data usually relates to physical changes. Okay, physical changes in the environment that is currently being monitored. Now, a sensor converts the physical characteristics or the physical variables, okay, and we have a lot of them right there on the screen: temperature, atmospheric, humidity, into a signal which can be measured electrically. Monitoring systems are different to control systems. Please, it's important to note this. If you write here, you're taking notes. Obviously, this is more like a teaching, so you should take notes. Regarding their output, I'll say that again. Monitoring systems are different to control systems regarding their output. Control system process the data. That's for control. Process the data and then make decision based on the data regarding which action to take. For monitoring, it only process and record the data. For control, it will process the data and then is going to take action based on decision that has been made, based on the comparison of the preset values. One way to describe the control system in chapter, I'm going to make reference to chapter 1, is real-time processing. We talked about data processing. We talked about a lot of them in chapter 1, and again, I would advise you to go back to that video and you watch it. We talked about real-time processing. Okay, so it's likened to that, because again, it's for control system, it's processing that data and then it's making decision based on the data regarding which action to take. Sensors continually sends data back to the computer or microprocessor. It's important for you to understand this process, the back and forth process between the sensor to the computer. Now, sensor sends data every few seconds. Sometimes it could be minutes, and it sends data when there is a change in the environment. But you ask me, Mr. Gerald, is it only that? See, the process is actually continuous. It's back and forth. It's not like it's going to send this and then stop. No, it's a continuous. It never ends. That's the difference between a sensor and a human taking readings. Now, the sensors that I use, or most sensors that I use in the monitoring systems, are analog. For the O level, you know sensors to be input, and that's what we've said. Why we've come to understand that most sensors in the monitoring systems are analog, computer on the other end can only process data in digital form. This is where it gets a little bit dicey, because the data will need to be converted using what we call the analog to digital converter, ADC. And the whole essence why we are doing this is so that the computer can understand that data that is being sent and it can be able to process it. I don't know if I'm actually communicating right now. Now, in terms of the output, it's usually seen on your screen. Sometimes it can be printed out, but most time it comes like a warning sound. Okay, especially if the monitoring that is taking place is critical. So you watch these movies. Yeah, I do watch some movies a lot. I'm talking about those crime movies. I do watch it a lot, especially when we talk about nuclear reactors. And you see that it gets to the point that maybe when the monitoring have been able to you know do its job, which is process and record the data. What the control would do now is the fact that it will process that data and then will make that decision based on that data by comparing the preset values and seeing that is more. For example, 0 to 5 is normal. Anything above 5 is critical. So when it's going to 6, it's going to give a warning sign that something is happening. The nuclear reactor is overheating. And the whole essence is so that you can be able to quickly check it. This is what will not be possible with a human. Okay, because a human can be able to send a warning sign if probably there's an overflow. Let's look at sensors. Now, we're looking at the sensors for the monitoring technologies. Now, right here is a table that is showing some of the more commonly occurring sensors. Okay. In retrospect, there are very few basic sensors. Okay. And of course, with several sensors actually being a combination of the other. So let's look at the first one, light / the ultraviolet sensor. Okay. Now, light sensor is right there on the screen. As the name suggests, we just measure the amount of light. Okay. There are many types of light sensor, but they all follow the same principle. When light falls on this type of sensor, what does it do? It generates what? Um, Electrical energy. The amount of energy is then converted to give a value for the amount of light. The amount of energy, okay, is then converted to give a value for the amount of light. There are so many light sensors, but they all follow the principle. They just measure the amount of light. Okay. For the ultraviolet, right there on your screen, I used to measure the amount of UVs. Okay. UV, specifically the UVB radiation, which can be dangerous to humans, especially causing skin cancer. Okay. Let's look at the next one. Temperature. Right there on your screen, the temperature sensor is used to feed data back to the computer. Okay, now right there, there's something I've written in your screen. It said the combination of different types of temperature sensor either change their electrical resistance or generate a voltage according to temperature. Okay, according to what? To temperature. Okay, this could be, for example, the ambient temperature in a weather station, the temperature in a river, or the air quality. This is very, very important because this kind of sensor is used to just send, or is used to feed data back to the computer. Okay, about like I said, we've looked at it. We've looked at the ambient temperature. Okay, in weather stations, to check if what's the temperature like. Okay, also in rivers and also in air quality. Pressure. Now, for the pressure sensor, it converts the force applied to its surface to generate electrical energy, which is then converted into values to represent the applied pressure. Okay, now these sensors are used to measure atmospheric pressure in weather stations. Okay, so you're converting that force that is applied to the surface to generate electrical energy, which is converted to values to represent the applied word pressure. The next one is humidity or moisture. Now, humidity are often a combination of moisture sensor and a temperature sensor in one unit. This is because humidity can only be calculated by knowing how much water there is in the atmosphere together with the temperature. Now, for a moisture sensor, it's not here, but probably you could just listen. For a moisture sensor, um, it's actually a combination of light sensor and a light emitter. Okay, as the amount of light transmitted depends on the moisture content of the air. Now, you will see that for a humidity sensor, they are used to measure the air humidity in a weather station. Moisture sensors are also used when monitoring soil quality. That was why I said it's actually a combination of light sensor and light emitter. So as the amount of light transmitted is dependent on what? The moisture content of the air. Sound. Okay. So the sound converts sound waves into what? Voltages or electrical signals. Okay, voltages or electrical signals which are converted by computers into values to represent what? Sound. Okay, sound sensors can be used in environmental what? Monitor system to measure what? Noise pollution. Infrared. Okay, now for infrared, all bodies, okay, poses thermal energy and therefore emits infrared radiation. Now, this radiation is converted into electrical signals as a result. Okay, right there on the screen, I had to put it nicely. Said this sensor can be used in what? Environmental monitoring For example, the Earth's surface temperatures can be monitored by the satellite. Okay, so what this is just saying as much as possible is our body possesses thermal energy. Okay, so it emits that infrared radiation, and what the sensor will do is to convert that electrical signal as a result, and that is why it is used in environmental monitoring to monitor the environment, changes in the environment as much as possible. Okay, so we have the oxygen, carbon dioxide, pH, um, turbidity sensor. Now let's take this bit by bit. For the oxygen, which is O2, the sensors measure the level of oxygen in soil and water. That's what the oxygen sensor does. Measure the level of oxygen in soil and water. Carbon dioxide sensor will measure the level of carbon dioxide in the air or water. And they are basically an adaptation of an infrared what? Sensor. pH sensor will measure the acidity of soil and acidity in rivers, lakes. And they're very simple. They're just similar to simple batteries and generate electricity depending on the number of hydrogens and ions in the solution, which can cause an electrode to generate a voltage. Turbidity sensor will measure the cloudiness of water in a river that is affected by what? Pollution. Now, it is worth noting that for turbidity sensor, it's actually a light sensor, usually placed at the right angle to a light emitter. The greater the number of particles in the water, the greater the amount of light reflected on them onto the sensor. Okay. So yes, there's also one that is a read switch. Okay. But it's not a sensor, but it helps to just measure rainfall. Okay. Let's talk about the uses of monitoring technologies. The first one right here on my slide is weather station. And there are many types of weather station. Okay. Right on the screen, ranging from sophisticated and complex system to a basic home-based system. And in this video, we'll be considering the type of stations that might exist in a school. Okay, this type of weather stations could be used to monitor the weather in terms of temperature, rainfall, hours of sunlight, atmospheric pressure, humidity, even the UV radiation. Now, what are the sensors that we're going to need right there? You can just pause the video and just tell me two. Okay, I'll just give you like 5 seconds. Okay, so we have temperature sensor. If you said it, bravo, bravo. So for the temperature sensor, it's just to measure the ambient temperature. We have pressure sensors, which is just to measure the atmospheric pressure. And we have light sensor to measure the numbers of hours of sunlight. Okay. The read switch, just to, which is not a sensor, but it's just to measure rainfall. And please let me know of other sensors you think. I think there's one or two in the comment section. Okay. Now, when the weather station is operating, the readings from the sensor are fed back to what? The analog to digital converter, and then sent to the computer. The analog to digital converter will convert the data from analog to digital so that the computer can understand and process it. On receiving the digital data, the computer stores the data in the form of a table, which could be done using what? A spreadsheet or database what? Package, so that it can be processed. The processing might consist of calculating for each day the highest, lowest, and mean temperature, the level of the UV radiation, total rainfall, hours of sunshine, highest or lower values of atmospheric pressure, wind speed, etc. Okay, these values also can be calculated for the months and years to date. Okay, the result can be seen can be an output in the form of a graph, okay, either to be a monitor or printed out. Okay, now please note that this happens automatically without the need for human intervention. Monitoring water pollutions. When we talk about monitoring water pollutions, right there on the screen, studies of water pollution usually happens when reference to bodies of water such as rivers, lake, and sometimes seas. There are basically two ways of carrying out the study. Okay, one is on my screen. There are two here. One is to compare the readings with those that would normally be expected, and this requires the lowering of one set of sensor into the river or lake. The other relates to the industrial pollutions, though it can be used to measure pollution from a farmer's field. Okay, now um, just to go a little bit deeper, okay, um, this process can involve inserting two set of sensors. Okay, one can be from upstream from the suspected site of pollution, and the other downstream immediately after the site. Um, Whatever that may be, farm or factory, the reading from the two set of sensors are then compared to see if there's any difference so that a conclusion can be reached as to whether the site is causing a pollution. Okay, this system operates the same way as the weather station. Okay, with sensor that is feeding data to an ADC. Okay, and then the computer processing these two data. Um, yes, processing these two data. Okay, the sensor involves okay, I think we have the temperature sensor, we have the pH sensor. Okay, the processes carried out is a comparison of reading with normal values if it's in the first method, or a comparison of values from the other set if it's the second method. Okay, so one is reading the normal values, the other one is comparing. Okay, environmental monitoring. When we talk about environmental monitoring, okay, we are talking about the collections of data right there on the screen relating to our environment. It can be monitoring sounds in cities. Okay, monitoring sounds in cities, in addition to other pollution produced by the motor vehicle. It could be monitoring soil quality in outdoor garden, and also in greenhouses, using pH, um, moisture, temperature sensor, and among others. Now, environmental monitoring is closely linked to climate studies. So it can also include, I think I can just talk about two of them, and then we move on. Detecting abnormally of high temperatures using temperature sensor. So people can be one of the danger. Two, it could be monitoring the level of air pollution using what? The oxygen sensor and carbon dioxide sensor. pH sensor also can also help in this regard, as they can help to provide the acidity readings. Okay, even to the extent of monitoring ultraviolet levels. That's excessive amount, which can even cause a skin cancer. Calibrations. When we talk about calibrations, okay, before we get down to what's on the screen, it's important to know that when sensor measure physical variables, okay, people believe that the results are always going to be accurate. Yes, because the computer is involved. However, for this to be the case, the sensor has to be what? Calibrated. Now, what's calibration? Calibration is making sure that when, for example, a temperature sensor is used to measure the temperature of boiling water, it causes the computer to output a value of what? 100 degrees Celsius. This is done by comparing the value of a sensor produced to a known measurement. Okay, so what are the importance of calibration? Now, the accuracy of all sensors reduces after a period of time. This is often caused by a constant use and exposure to the atmosphere of liquid that is being used. Another one is slight erosion of the materials the sensor is made out of. It's also bound to occur. And again, it depends on the type of sensor and how it is being used as to how quickly the sensor, but whatever the cause, regular calibration helps to maintain what? Accuracy. Okay. The sensor is only one component in a monitoring system, and devices like ADC may also deteriorate, okay, over time. So calibration is important for that reason too. Okay. Now, what are the methods used to calibrate devices? Now, let's take a look on how to calibrate a temperature sensor as an example. In order to calibrate the sensor, there's need to be some way of creating a known temperature. This can be done by using a heat source that generates an accurate temperature, or a mixture of an ice and water which can give an accurate reading for 0 degrees Celsius. The sensor, when activated, okay, generates a voltage which is converted into a temperature reading. Now, the algorithm to do this can be refined so that temperature reading matches the actual temperature. Okay, the alternative is to take readings from a sensor that has already been calibrated and use to compare the temperature readings of the sensor that is being what? Calibrated. So we have 1-point calibration. What's 1-point calibration? This type of calibration is the easiest to perform. It's right there on the screen talking about 1-point calibration. It's the easiest to perform. Okay, easiest to perform. Okay, then can I write that down? Okay, so is the easiest to perform. Is the easiest to perform. Okay, only one measurement point is needed. That's why it's called a 1-point calibration. That's why it's called what? A 1-point what? Calibration. So only one measurement point is needed. Okay, and this makes it particularly what? Appropriate, okay, to use with what? Sensor. The sensor needs not to be calibrated. Now, yes, it needs not to be calibrated, and this is because we talked about an appropriate method to use with sensor, which have to measure a set temperature or temperature range that is constant. I also talked about for the 1-point calibration that the sensor needs not to be calibrated against any other range of temperature, since it's not going to be required to measure this. Okay, this type of calibration is often needed for sensors which are constantly used at very high temperatures after some lost accuracy. Accuracy can be checked by doing a 1-point calibration every so often and comparing the result with the previous calibration. In order to carry out a 1-point calibration, a reading, take note, is taken from the sensor in the range being measured and is compared with either a pre-calibrated sensor or a known value. Okay, so the sensor reading is subtracted from the known value, which gives the offset. Okay, so this is very, very important. For 2-point calibration, okay, we have, for example, we could have a numbers of solution with different pH values that are being used. We could have maybe this is a graph. We could have 2 points, okay, showing sensor and then standard, which is most unlikely, even with the most inaccurate sensors, which produces the reading this far out. Now, how do I explain the 2-point calibrations? Okay, Now, sensor being calibrated is different to a standardized sensor by +1 at the lower end and -5 at the higher end. The calibration cannot be carried out by just adding an offset value in this case. No. Since the offsets are different for every page value, there is, however, a linear relationship between the two, and to calibrate the sensor, the algorithm will need to multiply each reading by 2 and subtract by 3. Now, this calibration compensates for both offset errors and what slope errors, so called. The slope of the graph has to be what considered. Now, to arrive at this conclusion, we need to compare more than one reading with a PA sensor. It is recommended to place sensor in solutions which are neutral to maybe your pH 7, and either one which is what acidic. Multi-point calibrations. Now, when we talk about the multi-point calibrations, what we are saying here is, for us to be able to carry out this calibration, at least 3 known temperature needs to be created, and the sensor readings at those what temperature needs to be taken as well. Okay, it is very, very important. Okay, so for multiple calibrations, we have at least 3 known temperatures needs to be taken. All right, let's talk about advantages and disadvantages of monitoring technologies. Okay, now for the advantage, computers can take readings at more frequent intervals and can read more than one variable simultaneously. Now, this is where humans are unable to take readings at a very frequent interval, as they need to make a note for each reading. Of course, when you are taking a note, it takes time, right? During which you cannot take another reading. Okay, human can only do one thing at a time, but this is why computer is very, very important in monitoring, because they can be able to take readings at more frequent intervals. Another one is computer can be left on to take readings at any time. It's right there on the screen. Can be left on to take readings at any time, day or night, and the readings are always taken at regular intervals. Now, it is very difficult for humans to take readings for a sustained period. Okay, now talking about readings always taken at regular intervals, humans can even forget to take those readings. Okay, however, for disadvantages, computers can be expensive to buy. For human, it will be expected to do the monitoring as part of their job. Also, for computer, it is also expensive to maintain. Now, computers, another point is computers can produce them automatically after processing the data. Now, it is for disadvantages here. Okay, what about for humans? Let's talk about for humans. If computer can process them automatically after processing the data, for humans it takes time for people to draw accurate graph. Yeah. Disadvantages here is the fact that it is quite difficult. It is quite difficult to program computers to interpret the result. But humans can interpret the result and are also needed to program the computer in the first place. Here we have results are produced automatically. Okay, after the readings are received by the microprocessor or computer. Of course, unlike humans that would take a lot of time to probably write them down. Another point is reading can be taken by computer, or readings taken by computer tend to be more accurate. Okay, obviously by compared to humans, because humans are subject to, of course, human error. Okay, now for disadvantages, the sensor can deteriorate after a period of time. Why humans will tend to be more consistent. I think that's nicely put. Okay. Control technologies. Now, a control system is one that uses microprocessors or computers to control certain physical variables. Computers can do this by maintaining certain physical conditions at the same level for a period of time, or by controlling certain devices which cause the variables to change. Physical variables can be controlled by computers and microprocessors, which includes your temperature, pressure, humidity, light, and moisture. We talked about in this class that control systems use real-time processing, and we looked at it in reference to chapter 1. And they make use of actuators to control devices. Although some devices are actuators in their own right, like motors. Okay, unlike in monitoring, in control system the output affects the input. For example, think about a room temperature being as being controlled by microprocessor, yes, connected to a temperature sensor and a heater. The temperature is input by the sensor to the microprocessor. Okay, so if the temperature is below a certain value, the microprocessor will send a signal to the heater to switch on, which is what? The output. The heater being on causes the temperature to rise, which will mean the input value has now what? Changed. So the output has obviously affected the input. So control systems involves continual processes. Let's talk about the sensors in control. The first one here we have electromagnetic field sensor, or you could just call it a magnetic field sensor. Now, what the sensor does is the change in the earth natural magnetic field is caused by the presence of a ferromagnetic object. For physics students, probably that will make sense. Now, this simply means, for example, when a vehicle is above the sensor, the metal in the body of the vehicle distorts the earth's magnetic field, so its presence is detected. The sensor is so small, so its installation and maintenance are easier and cheaper than an induction loop, which performs more or less the same function. Now, the magnetic field sensor and induction loop are used at the entrance to car parks to control barriers. Okay, but magnetic fields sensor can also be used to detect the numbers of spaces available. Okay, here in your screen you can see that they're also using automated car parking systems to help drivers park their car, and also in similar ways to ultrasonic sensor. Now let's talk about the ultrasonic sensors. For the ultrasonic sensor, it is made up of device that sends out waves with a frequency greater than that of the human audible range. Okay, so that humans cannot hear it, and a sensor that receives this wave, which are reflected. So it can be used to measure how far an object is. Okay, now it also measures the amount of time taken for the sound to be sent and received, combined with knowledge of speed of this sound wave. Now, okay, it can be used by the microprocessor to calculate distance. Okay, again, just to make all this clearer, it can be used in automated car parking, which will let the driver know if they are close to another vehicle or other objects, so they can park their car without hitting that obstacle. Proximity sensor. Now, one way to explain the proximity sensor is, of course, proximity sensor is a mixture of sensors that usually comprises of a device that sends out a signal and a sensor which receives the reflected signal back. Now, this is done with infrared beams. ultrasound, or magnetic field. Now, whenever you take your phone close to your ear, probably you want to make a call, notice that the screen goes off. That is because of the proximity. So when you take your phone close to it, right, so it does not or carry out any form of electromagnetic, it goes off. Okay, that's a good example of a proximity sensor. The next one is a touch sensor. Now the touch sensor, one type of touch sensor is used for measuring what? Fluid levels. Okay, fluid levels. Again, just to make it all clearer, this type of sensor right here is used. Okay, I think I can just change this to just it's used in detection devices used to measure fluid levels, such as what the cooling water level in a nuclear power plant, to ensure there is sufficient water to cool the reactor. Let's talk about actuators. Just as sensors provides the input to a control system, so actuator provides the output. An actuator controls the device, such as the valve, which allows water to flow through heaters or sprinklers, or in a greenhouse. It can be a motor which will control the opening or shutting of windows in a greenhouse, or switch which turns a heater on. It is essentially a device that turns an electrical signal from a microprocessor into what? Movement. I think I have a picture here. Now, here's a picture I want to talk about. A common actuator is a linear solenoid, which is basically what? An electrical coil wound around a cylindrical tube encasing what? A plunger, which could move in and out of what? The coil. They can be used to open doors or close valves or activate what? Electrical what? Switches. This is the case right here. These are the coils. So hope that makes sense. Uses of control technology systems. Okay. Here all the following examples are microprocessor controlled. The term computer can be substituted for microprocessor. So all these examples could be called computer controlled. Greenhouse, okay, or glass houses, greenhouses or glass houses. Now, they are used in countries with cooler weather, so people can grow plants that are normally grown in a warmer country. The sensor needed in a greenhouse are a temperature sensor, okay, to measure the air temperature in the greenhouse, a moisture sensor to measure the water content of the soil, a light sensor to measure the light level inside the greenhouse. So here you have the temperature here, moisture and light sensor, and what they are doing is just to measure the air temperature in the greenhouse, and also to measure the light conditioning as well. If it's dark, what happens? There should be light. Okay. We also have the light source here. We have the Windows motor that helps to open and close the entrance. Open for sunlight, close when there's only for sunlight. Sprinklers, what the sprinkler does here is just to ensure that there's enough water to fertilize or to nourish the plants. The heater, when the temperature is down, to ensure there's enough temperature. Okay, so hope that makes sense. Maintaining the required temperature Now, at the start of the process, the user inputs the required temperature, which is called the preset values, using a keypad. Okay, so let's look at this. Using a keypad or a number pad or a touch screen. Okay, now the computer will receive. So we have the first one we have here is, which I'm also going to wipe this, but the preset values. Okay, and this is done using what? A keypad. Okay, the computer will receive the data about the temperature of the greenhouse from the temperature sensor. Okay, from the temperature sensor. Okay, it needs an ADC to change the analog temperature, an ADC to change the analog temperature data to digital values the computer can understand. The computer will compare. If the temperature is below or equal to the here, if the temperature is below the preset values, what happens? Now it's going to send a signal to the what? To the motor to close the window or leave it closed if it's already closed. It also sends a signal to the actuator to activate. If it's below, sends a signal to the what? Window motor. Okay? It also what? Like I said, sends a signal to an actuator. Okay? To what? To activate. To activate what? The heater. Or leave it what? Leave it on. The layout of the algorithm will be, which I've already explained in my previous video in algorithm and flowchart. But let's look at here an algorithm. Okay, it's not as detailed, but just to give you just a picture of an algorithm which would describe the processes carried out by the microprocessor. Okay, assuming the preset value temperature has already been imputed to the computer. So let's see how we can do this. Okay, we're using a pseudocode. Let's see how we're going to do this. Okay, so let me get my cleaner. Y system switch on. Okay, for system is switch on, we have input temperature. Okay, the next one is if the temperature is greater than the preset values, then then send signal to window motor to what? To open window or leave it open. Also, is going to do send signal to actuator to switch off heater or leave it off. Okay, okay. Else, send signal to window, motor to close window or leave it closed. Is going to send signal to actuator to switch on heater or leave it on. Here we have and if, and then since you have a Y there, you can do what? End your while. Okay, let me do this. End my while. Okay. Okay, let me clean this. This is not the right indentation. Okay, let me see. Get my eraser. Talked about indentation, so it's going to be where this is. Let me see. This is going to be end if. Good. And Y here is going to be Y here. Okay. So notice that this is just a representation of how the microprocessor deals with the data. Okay, it does not contain all the steps which are involved in the system. The input of preset values needs to be done beforehand, and the analog to digital converter has not even been mentioned. Okay, let's look at maintain the required soil moisture. Now, at the start of the process, the user will input the required moisture level or the preset values in a keypad. Now, just the whole process, the microprocessor will receive the data about the amount of moisture in the soil, in the greenhouse from the moisture sensor. It needs an ADC to change the analog moisture data to digital values the computer can understand. The computer compares the sensor data to the preset values input earlier by the user. If the level of moisture is below the preset value, it sends a signal to an actuator, okay, which activates the sprinklers valve to open or leave it open if it's already open. If the moisture level is above or equal to the preset value, the computer will send a signal to the actuator to close the sprinkler valve or leave it closed if it's already. The whole process is continuous as long as the system is switched on. Some greenhouses have sensors which measure the humidity of the air as well, because some plants require high humidity as well as warmth. Okay, these have separate watering systems, one to spray water into the air, another to put more moisture into the soil. Okay, the principle of this is much the same as for the light described earlier. Okay, so how do we write this algorithm using the pseudocode? Okay, so let's see what we can do here. What I want you to do is this. Okay, I'm going to give this you as a classwork. So pause this video, try to see what I've said. Okay, listen to it again, what I've said. See how you can write the pseudocode for describing the processes carried out by the microprocessor. Okay, assuming the preset or the required moisture level has already been imputed to the system. So how are you going to do this? Y system is switched on. So Y system switched on. Okay. The next one is what? The other one we had input temperature. This one is going to be input what? Moisture. So here you have input moisture. The next one is if the moisture is less than the preset value. Notice that if the temperature is greater, then it should do this, else close. But since we're now using less, if the moisture is, what will happen? It's going to what? So you have, the next one you have here is what? Then. Okay, so if you're doing all this, congratulations. So you have what? Then send signal to actuator to open sprinkler valve or remain. Okay, remain open. Else send signal to actuator to close sprinkler valve or what? Remain closed. That if it's greater. The next one is the if is here, so you have to end the if. And then we have end y. Okay. Maintain the required level of light. Now, with regard to the level of light in the greenhouse, things are a little more complicated. When the light is not very good, a light source needs to come on so the plant have good growing condition. A preset value still needs to be entered. If the light value is less than the preset value, the light source needs to be activated. However, when night comes, note that that's why it's complete. When night comes, the light source needs to be switched off. Now, a second preset value therefore needs to be entered so that when the amount of light falls below that value, as at night, the light source is what? Switched off. The steps required in this process are similar in what we have done in the two slides, except that two preset values needs to be imputed. A light source is needed to measure the amount of light coming into the greenhouse, and the analog to digital converter is still required. Okay, so we talked about two preset values. Okay, so the first one is if the light value is less than the preset value, the light source still needs to be activated. And when night comes, what happens is the fact that the light source needs to be what? Switched off. So let's see what we can do. So how do we write this? It's still the same thing, but just that we're now having two preset values. So let's see how we can do this. Y system switched on input light level. Now level is here. Now I'm using an underscore so that it sees this as what? One word. Okay, that's why we use an underscore. So we see this as what? A one word. Okay, if you don't do this, it's going to say as two words. Then it's not going to work. Okay, the next one is if. So we'll input the light level. So if the light level is less than what? The preset. Okay, I have to clean this. Okay. It's less than what? The preset. We'll call this 1 since there are two presets. Okay. Then if this is going to be a nested if light level is less than what? Preset 2. Then, okay, send signal to what? Actuator to switch off light source or leave it off. Okay. Else send signal to actuator to switch on light source or leave it on. Now I have my end if here for the first one, and I have for this other one else. Okay, send signal to actuator to. So this one is for this if here is for the second preset value. Okay, so if this one is less than the second preset value, to switch off the light, else leave it on. So for this one, I have for the if this one is less than this, okay, this is going to what? Switch off. To switch off, light source, or you leave it switched off. Or leave it off. Then I will end my if here. Okay, I'm going to do my end if here because of space here. Let me see if I can do a screenshot of this. so that I can paste it in my, okay, let me paste it here. Okay, so I have this here because I want to continue from this. Okay, I'm just going to use red. I should use black, but I've started with red. Okay, so I have this. So here I'm going to end my if. Okay, and finally I'll end my while. Okay, all right, so hope that makes sense. I think black is better. Okay, so hope you understand the whole process. Now, for central heating system, right there on the screen, I have um, I've been able to atomize the step when user enter required temperature using keypad. The microprocessor stores the required temperature as a preset value. Microprocessor will receive the temperature from sensor. Microprocessor will compare the temperature from sensor to preset values. If temperature from sensor is lower than the preset value, the microprocessor sends a signal to an actuator to open the gas valve. If temperature of sensor is lower than the preset value, the microprocessor sends a signal to the actuator to switch on the pump on. Okay. If the temperature is higher or equal to the preset value, the microprocessor sends a signal to the switch to switch the pump off or and close the valve, and this sequence is repeated until the system is switched off. So the question is, we have right here a step which we need to convert to a flow chart. How do we go about it? Okay, so this is how we're going to do it. Okay, so I've talked about what I've done a video on algorithm and flowchart. Okay, so please, it's important to go through it so you can understand the symbols and the flow lines, which one is this, which one is that, as much as possible. Okay, because of time, I'm not going to talk about it here. So I have the start. That's the first thing here. I have the start. I'm going to draw it here. Okay, I have my flow lines. Okay, is a system switched on. Okay, another flow line. Okay, let me see if I can do it like this. Okay. Okay, so here, if I have no, what happens? If it's not switched on, what happens? Then it should stop. Else, I have this. This is going to be my input. I have input temperature. Okay, the next one is another decision box is temperature less than the preset values. This is a question mark. If I have a no here, what happens? Sends signal to what? Close valves. Okay, so I think I'm just going to take a screenshot. Okay, I can do this. Okay, actually, yes. Let me get my draw. Sorry, this is a no. They have to be a yes. So this will be yes. Okay, so this will be yes. Moving to this. So this will be yes. No, stop. Yes, can impute temperature. Is temperature less than the preset value? No here, and yes for here. Then I'm going to draw this. Okay, I'm going to draw this. Okay, so this is going to be send, okay, signal to open valves. Send signal to open valves, and I have another one. Send signal to switch pump on. Okay, so another one is this. So if this is going to send signal to close the valve, it simply means that it should send a signal to switch the pump off. Send signal to switch pump off. Send is also input. So I have an arrow here and I have an arrow here. And right here, they are connected. Okay, connected. And they go up. They go up till they come here. Which, remember, when we looked at it, we say it's continuous. Okay, so it's a continuous process. So we have this here. Let's look at it if we're making any mistake. So I have my start. Is the system switched on? No, stop. Yes, impute the temperature. Again, is the temperature less than the preset value? No. Send signal to close the valves? Yes. If it's less than, send signal to open the valve. And it goes down to send signal to start to switch the pump on, and then it sends signals to switch pump off. Okay, so this is off. Okay, all right, let's go on. So we talked about the fact that is what this sequence is repeated until the system is switched off. Okay, it's repeated until the system is what is switched off. So burglar alarms, micro control burglar alarm systems are used in many houses to protect against intruders. The sensors needed in such a systems are: one, the infrared sensors to detect movement of human bodies which emit heat. Two, sound sensors to detect the level of sound an intruder might make. Finally, the pressure sensor that are placed under a carpet or a rug to detect an increase in weight caused by burglar treading on it. Now, the microprocessor is programmed to have certain acceptable levels, and it only asks if the sensor readings are greater than this. An ADC is required so that data from the sensor can be understood by the microprocessor. Okay? In the event of detecting an intruder, the burglar alarm sounds an alarm and causes light to flash, and possibly sends a signal to the police to alert them to the presence of a possible what intruder. Of course, at the start of this process, the user will need to switch the system on. Control of traffic slash pedestrian flow. Now, apart from traffic light, the main use of a computer controlled regarding managing traffic flow is found on the motorway. Known as a freeway or expressway in some countries. Some countries around the world are introducing smart motorway, but this is particularly the case in the US, okay, the UK, Australia, even New Zealand. Now, right there on your screen, a smart motorway is a section of motorway that uses active traffic management technique. This system involves the use of a variable speed limit or being able to drive on the hard shoulder. Shoulder in the US and elsewhere, this is the area at the side of a motorway or other road where you are allowed to stop if your car breaks down at certain times. Computer constantly monitors the road and can change the speed limit or open the hard shoulder to traffic. Normally, traffic is not allowed on the hard shoulder and the rest course is displayed above it. Okay? If the traffic becomes congested, the computer opens up the hard shoulder by moving what? The red cross. Okay? So this is very, very important. Now, there are two types of devices, okay, computers use to monitor the volumes of traffic. One is rather like an induction loop, okay, which is positioned just beneath the road surface, and there are several of these sited at intervals of about 500 meters. The other use a sight fire radar, which involves firing of a radar beam at an angle to the roadside. The device measures the speed of the vehicle. It is pointed at by detecting a change in frequency at the radar signals when it is reflected back off an oncoming vehicle. This has advantage over induction loop system because it is not susceptible. Um, it is not susceptible rather to damage caused by potholes or erosion in the road. All this data is constantly fed back, okay, to computers, which then process the data and decide what action, if any, needs to be taken. If the road becomes very busy, the system can automatically lower the speed limit to open the hard shoulder to traffic. Okay. Now, computer can reduce the speed limit from 70 miles per hour to, for example, 50 miles per hour, okay, this slows traffic down and reduces the chance of traffic congestion. The decision made by the computer will often remain free of human intervention unless the decision appears to be unusual. However, computers are not programmed to react to a crash or are not allowed to close lanes. Okay, so this is another disadvantage of that. Okay, let's talk about car parks barriers. Right there on the screen, one of the most common way to detect vehicles in a microprocessor control car parks barrier is by using an induction, sometimes called inductive. Okay, induction loop buried just beneath the surface of the road in front of the barrier. As vehicle passes over the loop, it causes a change in inductance, which is detected by the loop. The metal in the vehicle causes a change in the magnetic field. Okay, this in turn causes a current to flow. The loop sends back data which is converted to digital if the computer detects any change compared to a preset what value. And of course, it sends a signal to the actuator. In this case, the actuator is the motor which, when activated, will cause the barrier to rise. Okay, there is usually a second sensor, often a light sensor, which is used to detect when the vehicle has passed beyond the barrier. A light beam passes across the space occupied by the vehicle. If the vehicle prevents the light beam, when it reaches the sensor, then the microprocessor keeps the barrier raised. Okay, when the vehicle is cleared of the barrier, the microprocessor detects that the light beam has resumed, so it sends a signal to the motor to retract and allow the barrier to lower. Just the whole process. Okay, so the process goes on and on and on and on. Traffic light. There are two types of traffic light systems. One is called the fixed time traffic system, which is controlled mechanically and turns the traffic light green or red after a certain amount of time. The computer is programmed to react to different volumes of traffic during the day, and often using the same method in car parks. Okay, the computer will receive data from induction loop by the way of the ADC and count numbers of vehicles traveling in each direction. These counts are then compared with the preset values, and the computer changes the traffic light timing or sequence as required by sending back to the control box the traffic light, which then operates the new sequence of timing. The whole process is continuous. Okay, for example, let's look at the example. If the computer is coming, or the car rather, is coming from one direction and none from the other, the computer will decide to keep the light on red for the road which has no traffic. When a sufficient number of vehicles has stopped at the red light, the computer will cause the red light to turn green and the other one red. It's the whole process. Smart homes. A smart home, right there on the screen, um, is a home in which devices and appliances are connected so that they can communicate with each other and can be controlled using command by allowing living by of course allow controls using command by anyone living in that home. So all the appliances are connected. Okay, and this is controlled by command by anyone living in the room in that particular home. Okay, a smart home makes use of home computers networks and a router, and an example of a WSAN, which means wireless sensor and actuator network. The command can be given by voice, remote control, tablet, or a smartphone. Okay, the most common devices controlled in this way right on your screen are televisions, light, burglar alarms, central heating, air conditioning unit. Okay, smart homes have developed due to the increase in the use of smartphones and tablet computers. Okay, and these are continually connected to the internet and can then be used to control any number of what online devices. Finally, let's talk about the advantage and disadvantage of using control technology. Let's talk about the advantages. Now, here you have on the screen, we just look at this, is the fact that the use of computer control car parks barrier instead of human parking attendants, for example, has increased unemployment. But on the other hand, IT technicians are needed to maintain the computers and programmers are required to program the system, so increasing employment. However, numbers of new jobs created tends to be far fewer than numbers of old jobs lost. Um, Again, um, right here at your right, the microprocessor control burglary alarm can give people a greater sense of security as they feel free from the risks of being burglared. Another one is smart homes can reduce the amount of energy needed to heat and provide light within a home. But they can lead to people becoming lazy since they can become over reliant on the microprocessor control devices in the home. They have also caused a sense of manual household skills, a loss of manual household skills, and prevent people from performing simple exercises such as walking around or using their hands and arms as much as they used to. Right here, we have the use of computer controlled traffic light has led to there being fewer traffic jams than when they are mechanically or time controlled. Okay, I can add one to it, which is air conditioning units in shopping mall tend to make shopping a more comfortable experience when the weather is warm, but can lead to an increased cost for shops, which in turn leads to an increased price for the consumers. Okay, so this is what we're going to stop, and this just helps us to just um, to summarize what we have done in this video, going back to the lessons for this video, talking about the sensor and calibrations used in monitoring technology. And again, we talked about the fact that when we are talking about calibration, okay, we said that for calibration, we have methods used to calibrate devices. We have three. We have 1-point calibration, 2-point calibration, multi-point calibration. But when we talk about calibration, is making sure that when, for example, a temperature sensor is used to measure the temperature of a boiling water, it usually causes the computer to output a value of that number of degrees. The second point is about the use of monitoring technology. Okay, and we said it can be used for weather stations, it can be used for monitoring water pollutions, it can also be used for environmental monitoring. We talked about the sensors and actuators used in controlled technology. And we said those actuators that are used for control technology, we have the electromagnetic field sensor, ultrasonic sensor, proximity sensor, touch sensor. And we also looked at how to write an algorithm and draw a flowchart. And we looked at it in the case of the greenhouse or glass houses. I want to talk about a very important YouTube channel called Ajiro Tech. Trust me, this YouTube channel is a giveaway. It's loaded with IGCSE, ICT, O level, AS, and A level. So trust me, is a giveaway. This channel is helpful for your group studies, your personal studies, and it has a proven track record of producing excellent results. So do me a favor, click on the subscribe button, okay, and share this YouTube channel with your friend. Trust me, that will be the best gift that you're giving to them. Thank you very much, and I'll see you in my next video. Bye bye.